Let's go for our third example of mutually exclusive and non-mutually exclusive events. So the probability that Louise will go out for dinner is 0.4. The probability that she will watch a movie is 0.7. The probability that she will do neither is 0.2. Now, I'm going to say that there is a possibility that she does both go out to dinner and she can go out to a movie. So we're going to draw a Venn diagram to represent this situation. So I think it's really important. So let's just say D is for dinner, M is movie, and neither means not dinner, not movie. So we're going to draw upon our experience of sets significantly here. So my universal set. For probability, if you add up all the probabilities, they're always going to add up to 1. Right? What is the probability of the weather today? Well, it's 1. I mean, weather happens. So I have 2 events here, and I'm going to call one D for dinner. I'm going to call one M for a movie. Now, I don't like that because it didn't give me enough room. Okay, come on, cooperate with me. M is movie. So we have probabilities in this Venn diagram here. And what I know is that all of, where am I here? Dinner. All of dinner, if I add all of this up, it's going to be 0.4. Now, if I add up all of the movie here, it's going to be 0.8. I don't know how much is in the middle. But what I do know is how much is neither dinner or a movie, and that is 0.2. So she doesn't go to dinner, she doesn't have a movie, is 0.2. Well, now I know that the probability of having dinner and the probability of dinner or a movie is going to be the probability of a dinner plus the probability of a movie. And since they're non-mutually exclusive, I have to subtract out a dinner and a movie. And I know that all of this in this space, I still don't know how much is dinner and I don't know how much movie is because I simply don't know how much is in between, X. So let X equal the probability of a dinner and movie. So the probability of a dinner then, here, this area, is going to be, well, the probability of a dinner and dinner alone actually, I'm going to switch tack here. I'm going to move this. The probability of having a dinner or a movie, well, the probability of having a dinner was actually previously stated as 0.4. The probability of having a movie is 0.7. So the probability of having a dinner and a movie is going to be equal to X. But we know that this area here that I've highlighted is going to be equal to 0.8. If I add this together, 0.8 is equal to 1.1 minus x. So here, x is going to be equal to, I need to perhaps bring x over to this side, move 0.8 to that side. If you solve this algebraically, you'll end up with 0.3. So what do we have here? I'm going to clean this up a bit. In the middle is going to be I figured out the probability, again, let's try this again. The probability of a dinner and a movie is 0.3. The probability of going to a movie was 7, but only a movie is going to be 0.4, right? All of the movie here is 0.7, so you have to subtract 0.3. And the probability of going to a dinner is 0.4. So only dinner is going to be 0.1. I have a lot of information here going forward. I've exhausted all of my sample space, as we say, and this situation represents the Venn diagram. Determine the probability that Louise only does one of these activities. So the probability that she only does one of these activities is the probability where she only goes to dinner or if she only goes to a movie. So B, the probability that she goes to a dinner, only a dinner, or only a movie is going to be 0.1 plus 0.4, and that is going to be 0.5. So she really goes to dinner or a movie and not both.